Okay, let's dive into a question that sounds so simple you might think it's a joke. But trust me, hidden inside is a paradox that has twisted the brains of thinkers for literally centuries. And it all starts with the first shape you ever learned to draw.
You know what a line is? I know what a line is. It's just this. A smooth, solid, unbroken thing you draw from one spot to another. It has a length, right? You can take out a ruler and measure it. It seems simple, obvious even.
But what if I told you that our everyday gut feeling about what a line is wrong? Or at least it's hiding a mind-bending secret, that this completely normal object is built on an idea that feels kinda impossible. Let's peel back the layers.
So let's start with that familiar, comfortable line we all think we know. We see it as one whole thing, but that all shatters the second we ask one tiny question. Seriously, think about it. If you zoom in on pretty much anything, a wall, you see bricks. A shirt, you see threads. Everything is made of something smaller. So what are the fundamental building blocks of a line? Well, according to modern mathematics, a line is made up of points. Not a few, not a billion, but a truly infinite number of them all squished together. And this simple-sounding answer, well, this is where everything starts to get weird. 'Cause see, these points aren't like little beads on a string. They behave in a super strange, totally counterintuitive way that makes you question what solid even means. Get this. Pick any 2 points on a line. It doesn't matter how ridiculously close together they are, you can always find another point right between them. Always. And then between that new point and the original one, yep, you can find another one. This process goes on forever and ever. And this leads to a really bizarre question. If you can always squeeze another point into any gap, no matter how small, can any 2 points ever actually be next to each other? Do they ever physically connect to make that solid line we see? And the answer is, believe it or not, no. Points don't touch. There's no such thing as the next point on a line because there's always one in between. So we have to stop thinking of points as tiny dots. They're not physical things, they're just locations, abstract positions in space that have no size at all. And this right here is where it all leads. We have a line made of infinite points, and these points have no size. When you put those two facts together, you get a fantastic paradox. Let's just be super clear about this. The official definition of a point is that it's just a location, a coordinate. It's not a thing, it's a where, which means its length is precisely 0. Zilch. Nada. It takes up no space whatsoever. Okay, let's do some really basic math. What's 0 plus 0? 0. What if you add 1,000 zeros together? Still 0. So what happens if you add an infinite number of zeros together? It's still 0. You can't add up a bunch of nothing and get something. And there it is, the paradox. If a line is just a collection of points, and every single one of those points has a length of 0, how on earth does the line itself have a length you can measure? How do you add an infinite amount of nothing together and suddenly get something? To solve this puzzle, we have to realize that we've been mixing up 2 completely different ideas of what a line even is. This is a story that pits ancient Greek geometry against modern math. See, the whole problem comes from these 2 clashing ideas. For the ancient Greeks, a line was the main event. It was a whole, complete object. Points were just little markers you could place on the line. But in our modern view, it's the other way around. The points come first, and the line is built out of them. It's a small change in words, but a massive change in thinking. To put it another way, the Greeks started with the whole thing and then identified the parts. Modern math starts with the tiniest possible parts, the points, and tries to build the whole thing. It's a total flip in perspective. And that is the absolute key to understanding this. The zero-length paradox, it doesn't even exist in the Greek way of thinking. They never say a line is a sum of its points. That idea would sound like nonsense to them. This is a problem we invented for ourselves the moment we decided a line was built from points. So how did modern mathematicians fix the problem they created? Well, they kind of sidestepped it. They basically said, okay, you're right, adding up the lengths of the points doesn't work, so we're just not going to define length that way. Instead, in modern math, length is simply defined as a measure of the whole set, calculated as the distance between the 2 ends. It's not a sum, it's just a property we assign to the collection.
But there's one last piece to this puzzle. How do we make our modern point-based line actually feel as solid and continuous as that intuitive line the Greeks talked about. We need a very special, very powerful secret ingredient.
And that secret ingredient is infinity. But not just any infinity. We're talking about an uncountable infinity of points. That's an infinity so dense, so huge, you couldn't even begin to count the points. It's this absolute seamless packing of points, with literally no gaps at all, that allows a collection of nothings to create the feeling of a continuous something. Ultimately, that's the bridge that connects these two worlds, the old school intuitive line and the new school abstract number line. They really only become the same thing if you're willing to accept the wild, weird, and powerful idea of infinity. Which leaves us with a much bigger, much more fascinating question to chew on. Does this paradox mean our math is just a flawed description of reality? Or does it suggest that math isn't a description at all, but a powerful language we invented, a language with its own rules and definitions, designed to help us wrap our minds around a universe that is way, way stranger than it looks? Something to think about.